So I wanted to introduce today's topic, which is fiberglass and carbon fiber wing repair, fuselage repair. And I've been interested in repair since I used to fly balsa, and I became professional at repairing balsa. But now I'm doing more fiberglass repair work, and so I think all of us are kind of upping our game in repair. And I first met Don at AeroMicro. He was behind the counter, and I was kind of surprised, like, here's a hobby shop, and the guy behind the counter really knows knows thermal duration. It just seemed sort of out of place. So I've been a fan of Don's ever since. And then I bumped into Dale pretty much the first time when Dale landed in a tree with one of your large planes. Yeah, and I think we had to, I think I helped him, I think we did the water bottle and the string over the limb and shake it, and then finally came down and did a nice nose landing on, I think, on a path, on a concrete path. And so I got to see.
Well, that was the second time that was in the tree.
Yeah.
The first time it came through the branches and ripped it to pieces.
And then later I saw the repair, and the repair was like nothing had happened. So I was very impressed with both these gentlemen, and I cornered them into talking today about fuselage and wing repair. So why don't we get started with you,
Okay.
and we'll cover this again.
Yeah, I'm going to cover it real quick. I do have a handout. I brought a few copies of really intense stuff because I can only cover the front of it. First bit of advice is if you're doing composite, Radiocarbon Art has a 3-set video on glider repair labs. And the first composite I totally crashed was the Explorer 2. There's now 2.5 that I'll show you. And I put it in my basement and just forgot about it. Then I saw the videos and it let me know what I could do. So it goes into a lot more detail than either my notes or any of our presentation comes out. But Paul Naton is not only an amazing flyer, but he's an amazing builder and repairer. And I highly recommend. In fact, I must have 100 plus of his videos.
No.
Yeah. So anyway, radiocarbonart.com. Amazing stuff. And a lot of the techniques is from that. This plane has had the misfortune of having 2 breaks. First one was here, second one's here, and actually this one broke twice. Because when I read up on it, I said, I'm using a sleeve, not carbon, wrap. And I said, I don't need to do toe. It should be stronger than this stuff. Well, it wasn't when I did some tests. So I went down and did it exactly like all the experts say. And just in a nutshell, the way both of these are fixed, and I'll show you the electric as well for the nose, is you get an angle iron, like 2 inches to a side, aluminum, about that big, about a foot. And you get a second one, like a 1 inch, and again, about a foot long. You bolt that here. So that's to align with your tail. The other one, make sure everything's straight. And what you do is you tape it up, tape the pieces back together with masking tape, and as you peel a piece back, you CA fix it. And you can use like anything, fiberglass or just the CA. The point is to slowly put the pieces back and put enough CA so it's rigid. And once you get that done, and you have to take the aluminum bracket, move to the other side, you have a piece that looks like it's original but no strength. Then you go in.
So there's a bar, you said there's some kind of bar that bolts the 2?
Okay, you take an angle iron, aluminum, about that big.
What an angle? Oh, that's like
Home Depot, Orchard Supply has.
It's like a sliding door.
Extruded
L-shaped
extrusion.
Okay.
Oh, yeah.
It just extruded, that keeps it rigid.
That makes the whole thing.
And so you can do it, sight down the seam. You can line the stab with this bar that you've put either place, and you can sight down the elevator. I mean the rudder, just to make sure everything is true.
Okay.
And you can also check your incidence. Now, lining this up straight tends to make everything straight. And so you're going to do it in 2 steps. One, when you replace the one side, and the second, when you replace the other side. Then you're going to put it back in, and I take a Dremel with about a 4mm ceramic wheel. I cut slots between 2 I'm a metric guy, so you'll have to translate, between like 2 millimeters and about 7 millimeters wide. And I have this all on a handout. And just do it about 2 centimeters apart, almost an inch. You're going to do them around. And these slots get filled with tow and warmed 30-minute epoxy. I never use 5-minute epoxy on anything that's structural. You might as well use bubble gum. It's about that strength. 30-minute works well, and I also use finishing 20-minute. I use, everything is Bob Smith. It'll be labeled AeroMicro, Sheldon's, Hobby King, whatever. But so you have these random slots. They get filled with tow. You tape it up, let it cure, check your alignment, take it off. Now put other tow in between that tow. So you've got about every centimeter, half inch, you've got tow.
How long are your slots that you make first?
They're between roughly 2 centimeters.
So just a
roughly
centimeter
an
either
inch
side of the crack?
to about 3 inches.
Okay,
The thing is to make them random, otherwise you're going to have a stress.
okay.
Then when it's all done, I take, by the way, I do very little hand sanding. Random Orville sander is my baby. Until I'm doing a final sanding, I never do a hand sand. So this gets sanded, I first take a razor blade before the tow and epoxy is hardened. It's still soft. You can just slice through it with a razor blade. Get it rough, let it dry. Any low spots, I'll make a mixture of microbloons, 30-minute epoxy, and black dye. You can get it Tap Plastics. And that fills in the low spots. If you have, because you're piecing pieces together and not going to be perfect. You sand it, and then I take, this is from, what is it? Guys in Tehachapi. They sell the sleeves.
CST.
Yeah, that's it. I've got it all on my cheat sheet. And I picked a 1.5 inch sleeve. It just goes around, it acts like a Chinese finger puzzle, stretches. And I put tape on either side, make sure it stretches to about half the tape. And then you put enough resin so it soaks through, hot resin again, usually finishing resin, called finish cure resin, 20-minute, although it takes much longer than 30 minutes. Then I take a piece of shrink tubing, fits over it, heat that up, it heats the epoxy. I don't get it really taut, just so that most air bubbles are done, work the air bubbles out, heat it with a heat gun, and that's pretty much this. And then I normally will sand it and shoot it with a coat of clear, like clear Rust-Oleum, what do you call it? 2 times. They're painter's touch. And that gives it pretty much the same look as the rest of the fuselage. Let me show you an electric. So this one, also there was you mentioned something about having all the parts. I don't sweat if I have a few pieces missing, because what I do is I make up a tow mixture of fiberglass tow, again, about that long, 1/4 inch, 4, 5, 8 millimeters, and mix it with the epoxy, and I slurry it in, make sure I get it inside, let it form a bubble, come back when it's soft, hit it with a razor, and now that's given a patch for it. And it works real well for holes up to the size of probably a nickel. So it's a real cool technique. And here's an electric. I hate to admit this, but I actually launched it with, I was having some radio issues. And it turns out the JR28, unlike other JRs and Spectrum, it really has open gimbal. I didn't know that. And when I sent it back to JR, they said I had graphs from Brigantino all on my RF deck. So now I know I'm keeping it in the box. But anyway, it caused me some problems. And but I was range checking, and I actually launched it in fail-safe mode.
Oops.
So it went out. Luckily, the power killed, and it dorked it. And this fuselage is broken 3 places here. 1, 2, 3. And if you look at it just quickly, it doesn't look like it's hardly broken. And what I luckily did is there's a company that makes a metal nose ring for it. That helped me align everything to the right. And again, I took the angle iron, bolted it here, that aligned everything for me, shot down the straight edge here, made sure the down thrust was the same. And on this one, there is no carbon on the outside at all. This is the spread toe that came with it. Everything was done inside with 3.5 ounce cloth and heated finish cure resin and a little bit of tow. I did the same trick but on the inside with the tow. Because this thing, we don't dork it, And this actually won the Summer Soaring Challenge for electric last week. So I was real proud. It gained, between that and a wing repair, which I'll show you later, it gained 1 ounce. So you can do this stuff really light, because what you're basically is putting back what was there. One other trick on all of these, like this one, I didn't do a real good job on this one. This one did a better job. But you sand the base thin skin slightly so you don't get a bulge. So you're actually going to create, here's the side of the, it works for the wing or the fuselage. So you got a break here. So here's the thickness of this thing is really an eggshell. You're going to actually sand it like that, just slightly. I have tendonitis, so I can't use this hand real well. But then when you put the cloth in, which is going to overlap to here, you're going to sand it back to its original shape. So that's a trick I've used, mainly on the wing. This I wasn't as careful with, but it's a cool technique where you don't see a big bulge. When they cool, I saw at the Summer Soaring Challenge, a guy had a Explorer 2 that had a white fuselage. He did the patch, then he put a blue racing stripe on either side and a white one to highlight. It looked like he just had a carbon racing stripe. I thought that was really cool on the Explorer 1 and 2, where you can do that. With those, you can't do the tubing technique or the sleeve. You have to get typically 3.5 ounce cloth, overlap it maybe 1/4 inch, and then I use 2-inch packing tape, the clear, just wrap it around. It works really well. Some guys use VHS tape as well.
Wrap it around the cure, till it cures.
I overnight, because everything I'm using is slow dry. So what I do is I usually will put it in one of my bathroom with a heater on, get it up to about 100 degrees, and just let it sit there for about 4 or 5 hours, let it chill overnight. That way there's no hassle with it. With that, I'll leave it to your comment on that. Yeah.
How are you heating up the epoxy? Are you just
The air gun.
Oh, okay.
Yeah.
So you apply it, then you warm it.
So what I do is I take one of those plastic cups, put it about that far away from the heat source,
Yeah.
and this is the type used for monocoat.
Yeah.
I get it until it's relatively thin. Then I mix in whatever I'm mixing, microballoons, tow, whatever.
What's your working time then?
Since it's 30-minute epoxy,
Aren't you an
that
accelerator?
turns out to be about 10-minute
Yeah,
epoxy
okay.
when you're done.
Have you ever used West System slow cure epoxy?
No.
That's very thin already.
Yeah.
So you wouldn't have to
The
heat it necessarily.
finishing, I use everything Bob Smith because I'm lazy, and Sheldon's has it all. But I know other guys have used the West. Their finishing resin is more like a thin syrup as opposed to honey. So, and I never, ever, ever use solvent with epoxy. It breaks the bond.
Yeah, no.
But you're using a finishing resin on your structural repair, which is your sleeve?
Mm-hmm.
That doesn't-
Remember, all of the toe and everything is done with 30-minute.
Yeah.
The finish cure from Bob Smith isn't a classic finishing resin. It's more like a top coat resin.
But does it have enough strength though?
It's harder.
It may be harder, but
Well,
like as
I don't know
opposed
if you
to-
guys
as
seen
opposed
me,
to a 30-minute epoxy.
I dorked this one into our hard soil
Yeah.
from pretty high up and no problems, front and back. This one has also 1, 2, 3 breaks in the nose. So this one was pretty severe. And again, the nose with the same thing, you do it just like you do Explorer 2, 3. This I use 3.5 cloth on the outside, a little bit of 5 ounce cloth on the inside, because there's not a lot of room to do towing. And tow was done, if I had a crack that went through here, I put tow at the top on the inside. Just like here, I extended the servo tray, I extended tow past it. So I have tow starting about an inch into the servo tray and going out to give stress relief. Most of the finish epoxy, all it's doing is giving the hard final shell, but it's plenty strong enough. Yeah.
Earlier, you said you were cutting like 2mm grooves and putting tow in that.
It's about 4 wide. If I go,
Okay. How do you Do you back so that the toe doesn't just goop down into the?
I take the
fuse, or-
ceramic, it looks like a cutoff wheel, but just a ceramic wheel. They give it to you whenever you go to buy it. I've never used them except for this. And it's about the right width for toe. Yeah, 4 millimeters, a little more than 1/8 of an inch. And I'll just take it, and you can see when you're going in, it doesn't matter if you get a few of the fibers, but you're just trying to get halfway through. This stuff is paper
So you
thin.
wet them out and then you just put them in and they don't fall.
Yeah, what I do
they
is
don't fall in the gap.
I pre-wet them out. Then I put them in, and usually that's with slightly warmed 30 minutes. Spread them out. They're going to be random lengths, so I cut them to the various lengths ahead of time. Pre-dip them with resin, twist them slightly just so they hold together, and then lay them in. The first one, I just do the 2-inch wrap around it, let it half cure, slice it off with a razor blade, do the other final sanding and microballoon with dye if you need to. And then just ready for the sleeve. The sleeve really just holds it together. Most of the strength I'm convinced is the toe is going in there. You're putting a lot of toe in there. You're sanding off most of it too.
Okay, let's move on to Dale.
First of all, Don's repairs work, his technique works, and everybody has a different technique, and everybody in this room's gonna have a different technique, and if they work, go for it. I mean, that's really what
Well,
it
that's why
comes
it's
down
good to
to.
hear too. Yeah.
Because I didn't see Paul in the cons thing. My background is more that I've done Phil Barnes vacuum bagging, slope planes, scratch building, you know, from bottoms up. So I've got lots of materials laying around that I can work with. And so in just years of fixing things, I kind of developed my own kind of thing. I only use laminated resin, Easy Lam or MGS, 24-hour type stuff, very thin. I just take the time, let it cure out. I find it cures pretty hard, it's easy to sand and work with. I have some broken plane pieces here that I was going to talk about, because when you start looking at crashes, the typical things that you tend to find, you see this damage coming across the wing saddle. Why is that broken? It's broken because of the tip strike. You get the torque of that whole wing going like this, and it basically torsions the whole thing and breaks it. So that's the force that made the damage, so that's what you got to resist. So when you go back to fix these things and you start thinking, why did it break there? Why did it break there? Why did it snap here? So when I start to fix it again, I've got to mitigate those kind of forces and make sure I'm strong enough to take those. So the tips are usually where the servo tray transitions to the shell, and you're hitting the tip, and it's basically loading the whole mass of the plane against it, and it's going to take the hit. This, I find, is always from torsion loads. I've actually broken one of these on launch by having a rudder servo go out, the plane's going off like this. You give it full opposite aileron to try to hold it, and then zoom it off the line, and the plane lands, and the zoom off the line torqued it so much it cracked the fuse off through this area. So that's the loading on the airframe. All of these.
You're the guys that's breaking the, you're the
There you
ones
go.
breaking the lines.
That's right.
I do break a few lines, but Aaron Lewis told me that's what you're supposed to do. Then he quit, right? So you've got to also understand with the fuselage seam is a weak spot. So when they do the seaming and they join the molds, you're going to have, you know, a problem maintaining integrity through that overlap, no matter how you go to fix it. So those are the kind of things that you have to make sure you address when you go fix it. Now this was a Bruce Lewis fuse that he had done his type of a bandage before, where I don't know the exact technique, but a lot of planes you've seen looking like this, where people wrap it, tape it, cure it, and it tends to work. I fully agree with the angle, the aluminum 1-inch angles. You put one on the top, one on the bottom, you sight down that seam, you get it all lined up, tape them tight, then you go in, and I'm same thing, CA is your friend. Piece it back together, anything you can, put that CA in there to get some integrity and positioning as a fixturing move. Works through all of this stuff, but it's just fixturing. So what I tend to do is I'll get it CA'd back together, and then I'll take, say, half of it, and then I grab the motor tool. I've got a whole bunch of tools over here I was going to pass around and show that I like to use, but the carbide tough grind bits. I don't know if you've ever seen tough grinds. Lots of different shapes, balls, angles, drums. I'll feather the whole thing. I mean, That's my difference from maybe what Don's doing. I'll take the skin, we've got a fracture point in the tube here where it broke, and I'll take it down as far as I can get it to where there's just a web of anything in there that's remaining. Because you've got a stress concentration at the break that's going to stay there if you try to patch over the top with another thing. You've still got this lack of integrity through that area. So what you're trying to do is, when they say feather, is you're trying to spread the stress through here with different layers being built up of cloth, mostly always carbon, always on different biases. But I could get into that too. How many people understand what bias means? Okay, people are comfortable. And everybody knows what spread toe is, and different weaves, and all that stuff about why we went to spread toe, and then why we've gone to the carbo weave, carboline.
What's the difference between toe and spread toe?
Well, toe is basically a round bundle of threads, okay, if you want to call it that. And they used to weave it, just like on a weaver. So you ended up with a cloth, and the cloth had all these stress concentrations where they went over the top of each other to make the cloth. And if you had a lot of bundles in those, you had a thick cloth. If you had a small 1K, 5K, the 12K, different weights of that. All of those created pockets. All those pockets filled up with epoxy. The epoxy was adding weight, not strength. All the epoxy does is stabilize the carbon so it can do its thing, but it doesn't add strength, it just adds stability like concrete rebar. When they went to spread toe, they took those toes that used to be round and they rolled them flat. And then they wove them very coarsely. And they made it, that's what they called spread toe. Now it became a lot thinner and a lot less transitions, less stress concentrations, because it was thinner and they had the same strength, less epoxy, lighter plane. So you're like, oh wow, spread toe is cool. Spread toe is the big buzzword, right? It didn't last but what, 2 years? And then Vladimir or somebody went out and said, why the heck am I weaving it? Why don't I just lay a whole layer in this direction, a whole layer in that direction, and bond them together? And now I'm even thinner, and I don't have any of the over and under stuff.
So this is carboline.
Yeah, so we get to this carboline, which is the new stuff, right? And with carboline, when you used to build a plane, anybody would, they want a nice finish, they had to have a thin outer layer of fiberglass, like 3/4 ounce, or very, very thin, to support the paint, and to make sure you didn't have voids. So you'd always have this first veil layer, as they called it, in the mold. That was, if you were building the plane, you would paint the mold, then you'd put this very, very thin fiberglass layer in to support the paint. Then you could go in and lay your structural cloth, and if you had bias, you're at 45 degrees all the way through it, and then maybe you had to have some uni to support it, and then you would go with your spar structure to give you the full integrity of the wing. You don't need that veil cloth anymore when you have the carboline. So they took a whole layer out of the plane, and that wasn't adding strength anyway, it was just making the paint look good. So now all of a sudden you get these Explorers down to 60 ounces on 4 meters because they're taking materials out that aren't adding strength and allowing it to function. So that's kind of the evolution from the old coarse weaved, carbon material to the spread toe to the carboline, and then removing materials that didn't add anything and getting a stronger, lighter plane. So I don't know where we're going to go from carboline, but
How about the cloth that's sort of a felt, just sort of a mix of fibers?
you need to use the engineering properties of the material as continuous strand. It's in compression, it's in tension, it's in torsion. And so by the angles are doing the torsional stability, and the long, spar direction is helping with the bending. So it's a combination of those loadings.
The spaghetti.
These things are such eggshells, as Don was saying. You can't believe how they're very dentable. They're hard to keep from getting just dented, even though they're carbon. But there's just nothing there. They just blow up like Formula One parts, because
Like
that's
this fuselage is probably a 32nd of an inch.
Yeah, there's very little.
There's not
in there.
much to sand and turn.
Trying to do something like this is really hard on this newer type of designs. I'm working with an old Explorer 2 here, and if you look at it, it's got the old traditional Kevlar carbon type material running down in the mold with a fiberglass outer layer, and there's a little bit more thick. It's not a heck of a lot, but there's enough there to be able to work with it. And I would, like I said, I put the layers in I tend to hand sand everything using a carbide sander. What I mean by carbide sander, I forget what the name of the
Permagrit?
permagrits. I got a whole variety of permagrits, and I just go to town with that and cut it flat, and then you know, another layer of resin, and maybe a finer glass on the last layer, and then you just keep working that until you get the
Permanent,
finish.
is that a paper or is it a?
It's a aluminum sanding bar with a sort of a brownish gray
It's a-
carbide material in
It's
it.
an extruded aluminum, very flat, very straight,
Where you get those?
Aircraft spruce.
or wicks. Anyway, it has a steel thing glued on and little carbide grit bits that are clad in copper. And they're very tough and they last forever.
You can buy a roll
sand-
of them with shapes.
You could
can buy
sand
bars.
glass with them if you want to.
Permanent grip?
Permagrit.
Yeah, they're like $30 for a sanding bar, but
Yeah.
you'll never buy another one. So they're a good
Never
tool to
stopped
have.
with a tool.
You know, you sometimes have to invest, Bob. So anyway, getting to this point, I'll work up to this where you put in a couple layers, you then check everything, and then you'll slowly work to where you're back to the surface. But the idea is that the stress is, you no longer have a void in the structure, the stress is spread over the area, and you're gonna get back to where you have an integrity in here. Now, I will also put toe through that area if I can. Now, that's just for like, mostly, if you're patching a place like up in here, one of these breakouts or something, getting on the inside is easy, and putting a small bridge across that with toe or with Kevlar if you have to, is a good way to work on the inside when you get there. Here, trying to avoid this kind of a look and repair is a good thing. What I wanted to, just to move on, since we don't want to run out of time here, you know, I blew up an Explorer 2 down in San Luis Obispo, and what happened is the tail joiner broke. Solid pultruded carbon rod. I'd had it for 2+ years and been flying a lot of it, and when you looked at the brake, it had a standard stress factor crack right on one side. So I lost the half the stab, blew off on the zoom. It was a pretty aggressive move, but it blew off.
So it only flew half as well.
The other stab lifting torsioned the tail off.
Oh, no.
Because you lost the lift on one side and there was enough force. And if you look at this thing, you can see the stress line that came through here as this was being torqued by the lifting, and where it broke right through here. And you can see the break on the back where it basically tore the tail off with that transition, and then all the parts came down, right? So
That's fine, you can.
Might as well.
what I did to repair that, and this is the luxury of flying the same model and having lots of friends flying the same model, is Bruce Lewis had blown up another one earlier, and he wasn't going to fix his, and so I borrowed it. And the tail part of this broke in a different place than my plane, which is the one over there. So having the luxury of having overlapping parts and multiple parts is a big bonus when you're doing this. So what I did in this particular case is I took just a small piece of carbon with plastic on it. One of the things you can see in Phil Barnes' tape is he loves 3M77 contact spray, and he'll build what they call composite cloth. So he'll take and lay out a whole sheet of carbon, and then he'll get a very light fiberglass, like 3/4 ounce or something, spray on the contact stuff, and then he'll laminate the two together basically with the thing. Now what that does is it stabilizes all the fibers. Now you can go cut shapes and do strips, and everything's, you know, solid. It's not going to fall apart in little strands in your hand. And so some also people will laminate a clear plastic layer on top of their cloth to stabilize it. And then if you turn it over, you can wet it out, roll it, get it all ready to go, and then cut the plastic, and you have a removable plastic piece that has kept the integrity of your shape. So that is also a release film. You know, it's not going to stick to anything. So if you take a strip, I might have some over there sitting around that have plastic on them. I intended to hand around. Like this particular piece here is laminated with plastic. And you can place that, say, inside your old broken part after wetting it all out, and put it across where you intend to put the joint, And then I put a balloon, like an animal balloon, the long skinny ones, and blow it up. And that's gonna put pressure like a bladder to give you a completely molded inside piece. And then you can go in and take that sleeve you made that's gonna perfectly conform to the part, and then you can position it, cut it, and then slip the two together, and you've got a perfect, alignment with an inner part. And I also put some toe down the sides of that before I made that sleeve. Then using the angle irons again and lining up the positions, bond it back together, and then I would go back in and do this, but I had that inner sleeve tear to stabilize it, and then build out, I would go in and build out the outer layer and then sand it smooth. So that fuselage over there is the result. I just flew it last Sunday to test it out. So this was a combination of Bruce's tail and my front with the inner band, and then completely keeping the profile the same, and then painting the transition so that it matched the stripes on the tail are all orange and the ones up here are all white. So this also had that same torsion problem from the prior crash where it torqued it. So I basically, after seeing it and getting it all ready together, ground it down as far down as I could so it was paper thin, and then laid some really, 5-ounce carbon on bias across that seam in layers to build it back up, so that I'm no longer having just a regular seam there, which is a small fiberglass overlap. Now I've got a solid carbon tie-in with a feathering, so that this deck here is way stronger than it was when it was new, but it's not any heavier. And same thing, this front of this plane had all the cracks and breaks up in here that were like that from the crash. And again, it was the same technique, CA it back together, a few strips on the inside to stabilize it, and then grind and feather, and then away you go. The only thing else I can add is that once I get to where it's all sanded and I like it, I go for the high build primers. I tend to use the SEM stuff that's 18 bucks a can, because you can get it in rose, white, black, gray, and so you can get a base color primer that's going to look good under your paint.
SEM primer?
SEM. It's Napa, Cook's Automotive sells it.
Automotive primer.
It's an automotive paint primer, and it's real expensive. Any of the high
Can,
end
by the can?
spray can,
Oh,
tall
spray
can.
can.
Yeah, it is an aerosol. But that's where I digress. If you look carefully at this, you can see that there's a whiter red here and a little darker red here and here. I changed from a white primer here to a rose-colored primer here, because it does affect your outer paint color. And I wasn't quite sure what the match was I was looking for. When I started with white, I wanted it brighter, but then I realized it was darker on the wing, so I switched to the other one. This is a automotive paint, 2-part catalyst cure paint. I can't live with rattle cans personally, because they never dry. They're always peeling, they never stick, and they're always gooey. And you just never get what you want. So this was a concept PPG paint that I bought years ago. It's no longer available. You have to work with the new system. But
Single stage.
it's catalyst.
Yeah,
It's a
but
3-stage.
it's
This is
considered,
a single stage paint. You paint
Oh,
it,
yes.
it comes out glossy.
which you can't buy in this county.
I bought it in Santa Cruz originally, but yeah, it's
You
hard.
might be able to get in Hollister.
But even if you get orange peel on your paint, I use an airbrush to do all my painting with, just one coat on there, and then you rub it out with the turtle green rubbing compound and buff the heck out of it, and then take it up on the McGuire stuff to where it just glosses out. And the next thing you know, it starts looking like it was when it was new.
You're talking concept from PPG?
Yeah.
Yeah, it's a 1-stage, but it's a 3-part paint, hardener, activator,
And
paint.
reducer.
Deadly stuff.
So it is deadly stuff.
Imron, I used to use Imron.
I used to use Imron too.
Yeah.
Polyurethane.
I use a
That
poly
explains
pressure
it now.
match.
I know.
But
Boom.
finding the color matches for Explorers, I have the orange, I have the red, and they tend to match very nicely with the European standards. But you can't get those good paints anymore and use them correctly. So the water-based stuff is where everybody's gone. I haven't gone there yet. People tell me if you learn how to use the water-based stuff, you can get really good results. But it's hard to find that, and
I'll cover that.
okay, so why don't we move on then to if anybody has any other questions, we can always answer.
Wing repair and go back to the painting.
I have a quick question.
What'd you make it for?
This mean in
The
here?
internal sleeve.
Oh, the internal sleeve, I think I just used 5.7 ounce like this. Just a piece of that.
There's no hard piece inside when you start with, you just lay it up.
If I had the ability to do what I did, because I could mold it on the inside of the place, and then I could cut and put the seam through that place, that's only something you can do if you have more than one broken plane.
Yeah.
And you borrow it from somebody and you make a little sleeve. If you can't do that, but we have enough broken Explorers around now, and the brakes, this is, we could, as a club, start sharing broken parts and keep those things going. So that's one way to look at it. But I've also repaired without the inner sleeve, CAing it back
And
together.
the push rods weren't permanently kinked or destroyed?
Or you want to get into push rod repair?
That's
That's another whole topic.
Let's put that another.
The push rods were all broken, the outer jackets were broken, had to splice the two together with tubes. You trumpet them with a Dremel tool, so the rods will go through, and then you got to bond them to the walls with magnets and piano wire. And that takes half a day sometimes to get it down that speed. But that's important stuff.
Just a quick question, when you're doing this multi-layer, are you doing that all in one go, one layout?
I'd throw 3 layers in there once and then, get my hands in there with a paper towel and work it.
All right.
And then put some plastic around it. I use the clear placking tape, works to get some tension on there. Just get that thing as tight as you can and then just leave it overnight and let it cure out.
And if you need more layers, you just do it?
Well, then once you start sanding it, you see where it sands and where it's shiny still, where it wasn't high enough, then you go back in and, I'll take days to fix this stuff. I'm not looking for overnight.
Does the packing tape leave kind of a gooey thing? Like I've been using electrical tape, and it makes kind of a gooey.
It's hard to get off because typically the packing tape comes, now I keep a thing of goof off, whatever it's called.
Yeah.
It cuts, it's like lighter fluid, and then alcohol. Get rid of
And
it.
paint thinner itself cuts that adhesive better than acetone or MK or, sometimes just regular paint thinner.
So you don't worry about the goo, you just remove it.
Yeah, you just wipe it down. Once you start sanding on it, it takes all the solvent out. But I think the packing tape is great because it has a release agent on the outside of the tape as well. So you could put a layer of packing tape in some place like this and then, put the parts together and then the epoxy is going to pop off because the packing tape release is built into it.
Pretty cool stuff.
Okay, so let's move
Okay,
away.
real quick on wing. I want to show you a couple of minor and major repairs. This is an Explorer 2. Actually, this used to be orange, and it crashed from about 50 meters, maybe a little more. And I had written it off. It had, like your fist was pounded into here, in about a quarter inch or more. Luckily, the spar was good. My write-up, I talk about a reflection moment. It's on your airplane, if you look, and if the spar, especially the main spar, is broken, then I write a check for Soaring USA for a whole new airplane. Because typically the wing is like 60 to 70% of the cost. Just the center section, 60 to 70% of the cost of the kit. So if you've broken this spar, I just buy a new airplane. That solves it, and you maybe have spare parts. This one had a major, like I said, incident here where it was buckled. Luckily the spar was intact. And this is the radiocarbon art tip. Again, I highly recommend you get his videos. And what you basically do is you pull out the pieces like a jigsaw puzzle. This is really damaged. See them together, and then I'll sand them down, again, to save weight with the Dremel. I just want basically a structure there to put something else on. So if I can get it within a few millimeters of the top, that's really good. Then I'll take microbloons and epoxy and smooth it down so it's still a little bit, maybe 1 or 2 millimeters lower than the surface. Then believe it or not, 5.5 ounce, 5.8 ounce cloth goes over here, and it's again sort of sanded like he was talking, where it's thin, it goes down to it's almost nothing at the fix and goes back up. But we're only talking, you've got to remember the row shell is only a millimeter thick. It's pretty thin. So you're going to get, what you're trying to do is get that back. Then I mask it off, and I take 60 grit on a random orbital sander. Not an orbital sander, but a random orbital sander. And this is, again, the Paul Naton method. That comes off. What you wind up with is in the center, it's like 2.5 to 3 ounce cloth. The edge is paper thin. So you basically repaired this section stronger than it was. You're really not adding a lot of weight, because by pushing it up and doing the micro balloons, hopefully you've gotten it to its equivalent of 2-ounce cloth in the center and 0 at the edge. And that's what, this is about that big.
To add to that, Don,
Yeah.
there's a tendency for people to be afraid of low grit sandpaper. Oh, you can't use 50 grit, you can't use 60 grit, you need to use 220 and above. Well, there's a point where you're polishing and when you're cutting.
That's very
And
true.
if you want a nice flat surface, you need to cut. And you need a sharp cutter with a low grit, but you gotta be very careful, because it could just go right through the thing. But if you come in like he said, and you were very careful with that 60 grit, you're gonna plane it flat. And if you went in there with 150, 180 or something, you're gonna start contouring it. And so, just the FYI.
And a couple layers of masking tape let you know if you're going to cut through or not. Because, again, the sander is pretty darn flat.
Yeah.
Normally, until the final finishing, I haven't hit it with a hand at all. Here's one in process. When this plane actually had a couple more crashes, it turns out I had a bad wiring harness. And it was giving me full up aileron. And I had 2 crashes before. I did a landing, and the aileron went full up. And I went, And it turned out I had a bad wiring. Even though I replaced the servos, the receiver, I never thought, it's the last thing you check. So while I was doing it, this root rib here wasn't quite, or the tip rib for this wasn't quite shaped right. So I reshaped it and actually wound up getting into the foam. And all I did on this one is, this is 3.5-ounce cloth. Same sort of thing. I sanded it down. This, all I've done on this is taken the epoxy and smoothed it, heated it, smoothed it with a razor blade, get it off, pat it with a towel. Then I'm going to go through, again, this is probably, I'm going to use 120 grit, because this is thinner cloth. Go down till the tape disappears, put new tape in, and then do probably first a micro balloon with epoxy, get that smooth, and finally the final coat of putty. You got to be careful what putty you use too. A lot of putties, when you hit the primer, well, this putty gets soft. That's what I did on this one. On one of the tips, you can see where this is actually, when I redid this one, even though it came out really nice, this is Rust-Oleum. The first time I've done Rust-Oleum, I've learned enough. It's not the rattle can. That stuff is really soft. This is from a pop open can with going through a low volume, high pressure gun. But it's not as durable. This is in the process of being repainted, and I'm trying new paint. Before I've used replacement for Concept 1, it's called Essential. PPG, you can buy it still. Delphite Essential Poly with hardener. That's what now replaces Concept 1. I repainted a green Sharon, and it looked like it new when I was done with it. I have to repaint 2 bumpers. We got both cars got under $1,000 damage from a hit and run, both my wife's car and I. So I can only get those colors in water base, that hue in California. So I'm going to be trying PPG water-based paint. It's a base coat, top coat. I'll let you guys know how that comes out. I'll probably be painting next week. That's what I'm going to paint this guy with. I'm going to take this down with 120 grit, back down to the, almost the carbon, and then shoot it with a 2-part poly primer. Again, I don't like rattle cans. If you can avoid it, if you use epoxy primer, it doesn't sand well. So there's a company local called Martin Color. They're the PPG outlet for the area, and they can give you tons of advice. I've been using them for a lot of advice because they know what works and doesn't work.
So you said that there's a 2-part water base, there's a base coat.
No, it's a single base water. It dries, believe it or not, in about 5 minutes. And then it's you lay all your colors on. You can lay all your colors on within an hour of each other.
Is there a clear coat on top of it?
Then after that, what you do is you take 400 grit sandpaper, sand it down, and then shoot it with the top coat is a solvent base.
But it's a clear coat.
It's a clear coat.
Okay,
So that's base coat, clear coat. They tell me it's lighter. Oh, no, compared to because I know how much the other paint weighs. Rust-Oleum, believe it or not, is actually pretty light. I built a pattern plane with nothing but Rust-Oleum, but about 10 years ago, and it came out pretty light.
That's the
So-
rattle can stuff.
No, I never use rattle can. It's a different chemical.
Yeah.
The rattle can takes forever to dry. I use acetone, not paint thinner, and it's a different animal.
This is hard to get to knife finish.
I have an airbrush and I have a low volume, high pressure gun. So yeah, I don't mess around with paint. This one was not a rattle can. This was all, I did use a rattle can for the primer. I used their white metal primer.
Surprisingly, the Harbor Freight stuff does work. I've
Good
got
thing
a
about
Harbor Freight airbrush, the two-stage, it works fine. I have the Badger, big expensive one. I use both. And the HVLP or whatever it is,
Yeah.
guns from Harbor Freight for $20 or less.
I got
Touch-up
mine at
guns.
Home Depot of all places. I
They'll
think it
work
was-
too, yeah.
It probably got robbed. It was $40. My original high volume, low pressure wore out was about $200, so that's really good there. Once you've sprayed with high volume, low pressure, you'll never ever go back.
Yeah.
This paint is real expensive. To do this airplane, it was part of a car repair, but I'm guessing the paint alone is about $200.
You can't even sell the old style guns anymore. Everything is HVLP.
Right, I didn't know that.
It's been like that for 15
It
years.
uses so much less paint, and if you're talking paint that's $60 a quart, it's amazing. It's less
It's a
overspray.
compressor and a gun.
No, well, it's the gun itself. You just use less pressure and more volume with the HVLP.
You need an air
guns.
compressor
Yeah.
too, right?
Well, you have to have an air compressor.
It has a pressure reducer in the gun, so you typically feed it, like if I'm doing the poly primer, I'll first do it like at 32 pounds to the gun, and then I'll lower it for the final coat, same with the water base, to maybe about 20, 25 pounds. But the gun itself drops it way, way low. I don't know what the math is. But the thing is, if here's the spray fanning out, you could put your hand here and not get paint on it. Where the other ones, it's like a sprinkler, it misses.
There's
Really
less
cool.
mist and there's less volatiles that go in the atmosphere. That's why they did it. It's
I wanted to really quickly finish the repair part, then we can go into paint. And in this one I had a recurring problem with, I never did a good enough job joining the spar box to the top and bottom of the wing. And with Rich Fleischer's encouragement, I actually cut back about 3 centimeters on either side, a couple, 3, and put in a ton of hot epoxy, and then went back, it was actually disjointed about here, and put in tow that bound the top and bottom. So I put in a little bit of tow with this wood spatula, tow going this way, binding the two surfaces together, clamp this. And you can see on the top, I actually had to put tow on the top to tie it together. And then when it was done, and you're always checking to make sure your spar still fits, you haven't crushed it. And actually I flew this main repair was fixed. This is mainly a cosmetic repair I'm doing here. And it went from, you could see it sort of wobble, to being just rock solid. But it's a real trick. I have in my write-up more details about it, but a spar box repair is really, really hard. And you have to basically overkill when you're doing it. And what I do is I put the bottom, I'll put very thin heated epoxy, open it, clamp it, dry it this way overnight, do the opposite, now it's bound, then I put it on one tip, one leading edge, like do this one with a box. You're basically creating another carbon box. Flip it this way, and overnight cure the top. So it takes about 4 days to do it. And before I was a little lazy and didn't do it the right way, then Rich sort of bitch slapped me and told me that's the way to do it. So I followed his advice, and like
I've
most
been a
things.
few times by it myself.
Yeah, so I half-assed it, and I could see it was weakened, and he did it right. The other thing to note is this one, you can see from the crash I had with the servo going up, I had a little delam of this is spread toe. So it wasn't a crack, but rather just delam. I'll go in there with a number 11 blade, hog the hell out of it. And then I'll fill it with very, very thin. I use super thin Bob Smith CA. It's thinner than water. That wicks in and it holds everything together. Then I'll take a little bit of fiberglass shards, milled fiberglass, and epoxy, heat it up and putty that in. And that really makes a solid repair. You can see the same thing like on a wing tip. G5, look longer.
Maybe while you're doing that, Dale could start and then kind of wind up.
Yeah, I just want to show this.
Okay.
If I can pull the right one in. Yeah, on this one, it had a stress crack from a crash. And rather than go in there and do fiberglass or carbon, the existing spread toe was still intact. Again, a little bit of thin CA, put it together. Then I did a slurry of fiberglass shards and epoxy with a razor blade, smoothed it in, and this is now as strong as the rest of the wing without having to use pump. So there's a lot of tips like that from Miner. This is an example of a,
It's been through the war.
well, this is another impact blow, and this wasn't major, but it was getting thin, so I used, and the servo was right on the other side, so I didn't have the luxury of puttying it out. So I just put 2-ounce cloth. When I'm done, next I'm just going to put microballoons, epoxy, and putty it up, and that's going to be the same
Looks
strength.
like you got to practice a lot on that wing.
What?
You got to practice a lot on that wing.
Oh God! Well, this guy's been crashed so much that when I bought my new Explorer 3, I said, okay, I'm gonna do this right. It's more of the love of doing it, because I figure when I first built this, it took me about 100 to 150 hours to fix it, and that meant I was paid about 10 cents an hour, to do it. Okay, wing.
So, back to the story. When you go and decide whether to fix it or not, you also have to look at what you're going to end up with when you're done. And if you're going to be fixing a wingtip and you've got a lot of repairs out in the end, you're going to add mass, and the polar moment's going to get screwed up, and the plane isn't going to fly right, no matter how light you try to do it. So when you're down at the CG, you're down at the root, or you're in an area where you added lead anyway to balance the plane, you can be a little bit more, constructive and not worry about the end result because it's going to fly fine. But when you're working on wingtips and you're adding an ounce to a wingtip, it's huge on how it's going to happen on a 4-meter. So at some point you punt and you have to give up. But at some point you keep trying until you get there. So I'll just try to embellish a little further. This was a spread toe wingtip that got a hit on broke the joiner box out of here. And so in this particular case, this was all shattered. And this area was all shattered. But again, same technique, Scotch tape. Because it was spread toe, there was a lot of little overlaps that delaminated and fractured where all those were, but there was overlaps again, but they were open. So by putting them all together and taping them all back and then thin CAing it from the inside and flooding it, it put the integrity back in the skin, and I didn't even worry about the rotocell or the inner web, because once I had that rotocell soaked with thin CA, it rigidized the whole thing again and gave me something to work on. And then you could go in and sand it, smooth it, and then I would go in with like a thin layer of 3/4 ounce fiberglass and cover it and then wet sand it down to just get the integrity. But I'm still using the carbon that was there. I just had to get it all back oriented and then get it back in the structure. And when you're out on these light things, sometimes you stay with CA. You don't even go to epoxy. The CA does a good job if you can get it back into its right structure. In this particular case, the joiner box was blown out. So what I would do is I had a composite cloth where you had the bias and then a thin veil to hold it, and I would cut slots on either side of the joiner so you could have a window to get in there, and then you would relaminate another whole bias cloth on each side of the fracture. And try to also, if you get in there and feather out the fracture and put some toe across it and really get the integrity through the joiner box. In this case, again, our genuine, friendly, used Explorer man, Bruce Lewis, had an old broken wing he wasn't going to use. And I had a bunch of destroyed parts. So I actually cut, you can see in here, this, and this out of this wing to a nice edge, and then took the other wing and cut the same piece, and then put the same skin of the same airfoil right from the drag spar up to the seam. And then once I had it all in position, I feathered it down through here with some light cloth and then sanded it back down. And so there is a junction in here, and then repainted it to match. And so that was to, reclaim this particular wing. Now what I did bring,
And that was a new joiner box too, when you did that?
it was the old joiner box
All
with
built with a new
the
top.
old root rib, but a new top skin that was cut out of another wing and joined in. So that technique is very usable, to use old parts that are good from one plane, crashed here, and then use that, you can mix and match it if you're careful. The key was not adding too much weight. So in the end, I'm maybe a half an ounce heavier. I can tell the difference flying it. But I also made the go to Soaring USA, buy the new Carboline X3 tips, which go on an X2, and get 2 flights out of them before they blow up at a contest, and go in. So this is going to be a project that's coming. So some of the things that you can see I've got fractured tips, I've got seams in here, I've got a fracture through here, a fold through the aileron, I've got this, but I've got all the pieces. So I got a chance, okay? But there's a key to this whole thing and the way it failed. The spar structure is still intact, and it's still good up through the tip. It flexed, but it didn't break, but the skin broke because it's so thin. But what you will see is that the D-box opened up at the tip. Okay, so you can get in to the D-box area here, or maybe it's the other one. But also the drag spar delaminated back here. So when you start prying this open, you can see how it's unglued from the back. Well, I can prop this open all the way down the back, and I can see the whole inside structure. So now I can come back with my Scotch tape and get this thing all positioned and open it up from the inside and thin CA it. Now sometimes I can also go in, if there's a depression or something, put double stick tape on it, and then put a solid piece of something, plywood or something, and have the tape hold the structure. And then when you go in with the thin CA, you already got the plane established to where you want it to secure. And then it's going to give you the outer skins back in shape. And so I'm going to intend to fix these because I can get in from the drag spar point, and then I'll have to work through these. I bought some Carboline material for 25 bucks. Carbo Weave, the guy in Georgia sells this on the website on RC Group's materials. You get, it's double that size for 25 bucks. But now I have some Carboline material, and I'll cut small strips to use when I feather it down and try to get the skin back with it. Haven't done it yet, but this is on the list. But again, this was a tip strike from the, what broke on that one? Oh, I tail wrap. I went in the bucket too deep, wrapped the stab with the line, and it just came down, and then it came down and hit the tip, and it took out this tip. And then I was using these tips on this fuse at the time when this blew off, and it took out the other tip. And I actually had a spare set of tips, so now I broke a left and a right. So I ended up with a good left and a right on my good plane, and now I have 2 broken lefts and rights to fix, and then I fixed these. So again, same colors, mix and match, same plane, same wing, parts go together. Think about it when you buy something, buy 2. Then you can keep one flying while you work with it. So other than that, I don't want to go too deep because we'll run out of time. But
Good.
everything can be fixed, but
Good.
you're worried about the wing. That's what you're worried about. Did you want to go into painting or anything?
Pardon?
Did you want to go deeper into painting, or do we do it? Any questions? We're not getting any questions.
A lot of the painting, you just follow the instructions on the paint. And you just keep in mind, when they make these, they're not using primer. They're just doing a mist coat of white over that. So if you go and put a thick coat of white, you're going to have a big white splotch. So sometimes in a repair, I'll do a mist coat of black primer, just a mist coat to get it close, sort of what he was doing with the fuselage. Then when I put the white on top, it blends. I've done that with stabs. I had a stab, I had to do some.
These newer planes, they're not putting the color in the molds, are they?
Yeah.
They're still putting colors in the molds
On
first
the wings,
on the wings.
yeah, but not the fuses. They're just doing it. I don't even know if they put a clear coat for UV stabilization of the epoxy. But they're basically molded clear.
You know, I talked to Rich about that, and he said that most of the good epoxies now are pretty stable.
Stable.
So they're probably just doing that.
Here was a case of the other wing, which was really mangled on the bottom, but I wasn't going to worry about putting too much weight in here to make it look good. I just wanted the integrity back and some reasonable aerodynamics. And I just used a light coat of black primer. Very light mist just to get the color, but again, I didn't want the weight. I could have made it look nice and glossy, it could have been filled in, but it's a tip.
It's the bottom.
So it's structurally strong, but it's not.
Right, so any other questions, just stick around, we can ask them a few more, but let's give these guys a round of applause.
I got two more things to tell everybody. If you don't have a set of these carbide grinding tools, buy them, you'll love them, you know, for your Dremel, all kinds of shapes and things for like 12 bucks or something, I think.
Harbor Freight has a littler.
Same thing.
About this.
That Harbor
Yeah.
Freight?
I think I got this from that model maker guys in Florida, whatever it is that comes around that wants to sell you stuff. The model shipbuilding guys that have all kinds of hand tools and stuff, but it wasn't bad, but I have the Harbor Freight one too, because once you start using this and it just cuts so nice through carbon, and it's like if you're cutting the wing skins to put control horns in, and you just go, and it's like perfect. Like, why was I ever trying to do it with anything else, right? So getting a good set of the grinding bits that are the diamond, they're diamond coated grinding bits. And the same thing
The
from
West is expensive.
Harbor, they've got the wheels, the diamond coated wheels, and you can cut really thin through carbon really nicely.
Been looking all over.
And they don't shred.
They don't shred, they don't do anything.
I had one for years. They do bad, it went away.
Let me-